So there is a lot of content to cover here, and I will be fast, but these are all the experiences that we have collected trying to introduce agentic frameworks in Amazon. I work in the team that is supporting the infrastructure for the website. It's a very nice way to start the talk by showing a typical alarm that the on-call engineers are receiving about an environment that they don't know what maybe this environment is, because they are supporting some hundreds of thousands of API services behind the website, and they receive a severity 2 incident, and they have to figure out what is happening. So they will open their favorite Grafana dashboard, they will open their favorite CloudWatch and dashboard, probably the infrastructure description of the service that they support, even the documentation or how to query the logs of the ALB that is serving this particular service in order to figure out what is happening. Why do I have 500 errors, for example, in my CloudWatch metrics? And this is very typical that most probably you can relate, because I've seen this happening in a lot of different businesses and a lot of different teams. And there is a human cost on this, because you will have, eventually you will end up to trying to figure out what is the service that I'm supporting, and is this, in this particular case, is it a deployment that I need to change, or is it that I have to tune in this configuration the scaling pattern and how many requests per second should I have for my target in order to properly deliver? And this I have to make a decision. Should I reduce it, or should I what should I do? And this is the human cost of the problem. And the question that I have to pop up is, how can our systems help us think? And the talk is going to go through this process of we are used to, in the typical SRE scenarios, we are used to work with scripts, and then we move to automations. We are introducing CI/CD pipelines, and then now we're entering the world of cognition and the world of understanding through the use of agents. And in the space of scripts, we have playbooks, runbooks, however you want to call them. In the space of automation, we are introducing the standardization that we need across our different environments to support, in a way, the majority of the different services that we support. And finally, into having agents that can reason and understand what task do they have to perform, as we have seen also in the previous excellent demo. So the message I want to pass here is that we are moving from the scripts and the automation that we used to do into the cognition, into understanding, into giving to the agent the ability to understand what it needs to perform. The agenda for today is that we will look at a little bit of the data behind it, the topic of reasoning, how the humans can cooperate with agents, how do we evaluate the prompts that we have written, the data set that we have collected and created, and which are some future steps for us. I did borrow some nice examples with credits here on the Wikitech team, because I wanted to mention that we have a lot of playbooks, we have a lot of runbooks, we have a lot of institutional knowledge that is reflected maybe in wiki pages, in documents that have been written, and there are best patterns on how do we approach a problem, if it is a traffic drop in the load balancer, let's say, or if there is a disk space full problem. And previously, we used to have a lot of fragmented interfaces. Like we've seen that we have to find the tickets, find the incidents that are happening, maybe correlate some other incidents that are related to this particular service, query the logs of the load balancer to find which particular clients are generating these 500 errors maybe, or which dashboard do I have to look? And the consequence is that we spend a lot of time on the navigation during the process of troubleshooting as an on-call engineer, the situation that is happening, rather than spending the time that we want in the reasoning or taking the action to fix the problem and close the incident, close the ticket. And this is a problem because the MTTR is the hit that we get from this time that we spend into navigation. And I got some quotes from our Slack, which are matching this pattern. Has anyone seen this problem before? Because our engineers, a lot of times, cannot find similar problems in our internal wikis or in our internal discussion groups, and they end up to their team asking, guys, have you seen this problem before? Is it something that maybe someone can help me? And most probably they will get a great answer telling them, you know, this service has this special condition, and this is great because they will solve the problem and they will move on. But this institutional knowledge, this tribal expertise is lost because it's an answer in Slack, and it will never be recorded that this is a configuration pattern, let's say. So yes, the message here is that this institutional knowledge is a content that is not accessible by an agent or by any human in the future, especially if you are deleting the messages over time through Slack and this communication is being lost. So the problem that I want to highlight here is that the scaling problem is that the more services we have to support, the more complex this system is becoming, and this collective expertise that we have in our support team, in our on-call engineering team, is fading away. It drops. And I have my favorite here, Death Star picture from our CTO telling that this is someone created a graph of all the connections between the services that we have to support for the backend. So what do we need? I have some asks here that we want to end up to building something that we want to have a mechanism from a single prompt, if you like, from a single hit, to gather all these metrics from the dashboards and the search logs and the relevant tickets and the runbooks and return a hypothesis, and this is the business problem that we are trying to solve in our group, a hypothesis of what are the candidates that maybe can solve the problem. What is happening? Is it a memory leak problem? Is it a target group that is missing some targets with the workers behind it, with the nodes, etc.? And the auto context card is that from an alert, we want to collect. So we get a ticket, we get an alert, a notification in our paging system, and from that, we want to fetch all the data about the service, about the region, the configuration, the topology, who is the on-call, what was the last deployment, the recent config, and all this information within a time frame that can facilitate the on-call duty. That within a time frame of 30 seconds, let's say, bring all this relevant data to the ticket even to support the engineer that is having to deal with a lot of tickets during their shift. We also want these same tools, the same handlers, and then MCP tools are adapters that can provide connectivity to the documentation. So both the humans and the agent can use exact same commands. So we can have the agents that are executing the MCP tools and fetch the relevant data, but we also have the humans that are able to reproduce the execution of these tools and perform these activities. And we will see later why this is important. The second topic on the nomenclature, the specific lexicon of the organization. For example, internally we are calling our load balancers, we are calling them tardigrades. Tardigrades are some animals from the microscopic kingdom that are not relevant to the load balancer. But because we are calling them internally like that, the general purpose LLMs that we are using do not know this information. So yeah, if the ticket is saying that there is a problem with a tardigrade on and is generating a lot of 5xx errors on this service, it's not getting the proper relevant information in order to fetch from the knowledge base the documentation on, let's say, the load balancer. And for that, there are techniques that you can generate the embeddings for the knowledge base based on the information that you can annotate during the ingestion of your knowledge base. For example, in that case, I would add a dictionary of what are the words, the internal organizational words that we are using in order to improve through the indexing process the ability of the LLM to understand the specific domain within our business. Last slide on what we need. We've seen earlier the deployment and the fix, but as we are operating a production environment, we want to introduce these guardrails that we want the human to be able to approve and apply this thumbs up to the decision of the model to delete the PV or to deploy the change on the deployment in order to fix the problem. So any change action is proposed to have the previous result of the execution of the agent with all the thinking and the dry run preview, the reasoning and the ticket link and the final human confirmation that this action task should take place. And introducing some SLOs here, 30 seconds to the first hypothesis from the agents, thumbs up from the users or thumbs down on the response, whether it was accurate in order to help retrain and move on. Yes. Now, let's create all these handlers in our MCP tools, and let's build all these tools, the metrics fetcher, the logs fetcher, the tickets fetcher. We've seen examples with MCP tools. And let's create this bookshelf, this catalog of MCP tools that are available to both humans and agents in order to perform these tasks. And let's connect them to the data stores, our Prometheus for the metrics, the tabular data sets that we might have with our configuration, with the costs, the different APIs that we can integrate in order to provide to both humans and agents the ability to have a common interface to address the data that they need in order to perform an action. So they can collaborate and cooperate into the resolution of an incident. And our favorite tools from the open source community is they are coming with their own MCP client implementations. LangChain and the Strands is the equivalent of AWS agenting system library that you can use, and it comes also with an MCP client. An example of a human, for example, CLI that a human might want to interact with is, I just ran this screenshot that what IAM policies do I need for my Lambda role in order to consume some SQS messages. And bam, it gave me this list of, you need the receive message and the delete message and the get queue attributes. Very typical scenario that I always forget which type of policies do I need to add in my role. The same with the agents. If I would use the strands, for example, I hope the font size is okay for you. I would do the same question, what IAM policies do I need for my Lambda role? And it would go into this thinking process with the agentic loop to understand what tools do I have in my capacity, in my catalog to execute and perform the action. I need to use the tool search documentation. And then I've got this information. I want to use the tool read documentation. I fetch the particular documentation with a Lambda permissions and the policies for accessing the SQS. So the message here is that we didn't build AI wrappers around our tooling. Is that we extended our existing platform to include AI operators. And the typical problem that we have, especially with our security, is how do we ensure authentication in this? And by having the ability to have the delegation of the role of the human in the tool to execute and properly conditionally give the access to the data that it requires is something that is handled through the user session if it's a human that is querying the agent or the MCP tool. And in the case of the agent, again, it's the IAM role of the agent that is assumed by the Python runtime or the Boto3 library or whatever someone is using in order to get the authentication token. So we are moving from the world of building tools into a world of supporting reasoning. And I'll take just a few slides here on a bit of theory. I want to discuss a little bit of prompting techniques and a little bit of knowledge base. I will be very fast on this because I just want you to know it. And if you want to spend some more time on this in details later, this is something that you can do. There are currently, as far as I know, 3 prompting techniques that most of the people are using. And there are the chain of thought, plan and execute and react, reasoning and action. And the difference, I will try to highlight quickly the difference between these 3 prompting techniques is that we don't, in order to facilitate the agentic loop, execute a particular series of commands, It doesn't have to be sequential, but we can give some instructions to say that you need to go through a list of steps. You need to do an observation first, and you want then to do interpretation, and then you want to come to a conclusion. So we can give these hints to the agent through the list of steps, and then it will perform the actions that we expect them. In the case of plan and execute, it's a different approach, a different paper that discusses how first you describe the plan, and you expect the agent to build the plan and document it and say that first I will fetch the metrics, and then I will extract the relevant patterns, and then I will determine, and then the second step is the execution of this plan. And through trails, a configuration in the agentic framework, you can store in the form of logs what type of thinking and what type of tasks did it perform in order to come to this conclusion and finally execute. And finally, and that beats the state of the art is the reason and act approach. That is, through this pattern, is using the thinking process, the reasoning process, documenting the thought, performing the action, and executes. If you see here, repeat this loop as needed at the bottom. Finally, when ready, output the final answer. So it is challenging itself to think, did I answer the question properly? And like with the GANs in the past, with the generative networks, if you remember that we had this friction between a generator and someone who was challenging the thing that has been generated. And in that case, we have something similar, that we are entering this loop of, I think I should do that. Are you sure you want to do that? Because it did give the proper answer. Okay, maybe I need to do that. But so this friction between the different iterations of the loop is giving very good results, at least in the academic space. Second lesson for today, the knowledge base. Getting a nice screenshot from the Wikipedia Foundation here. We have an incident that happened in a particular date, and we have learned something. This is the root cause analysis document. This is the timeline of events. This is the executive summary. Is this a learning? Yes. Can I introduce it in my knowledge base in order to get this learning in my next iteration of the incidents that are coming? Yes. How can I do that? I generate some indexing in my database, in my OpenSearch in that case. What else can I do? I can generate embeddings for this. I can use the Amazon Titan embeddings, for example. An embedding is a vector string with all these floating points. And this is generated automatically by the frameworks that provide this capability. If I want to plot it even, I can use UMAP to reduce the dimensionality from a large amount of dimensions to just 2 in order to put in space and do some calculation that for this particular question, for example, search term AAA initialization, I would fetch all the relevant documents that are in that particular space. And I would fetch these documents and I would return it to the context through the RAG process, through the tooling that is giving me the ability to inject in my prompt the relevant documents to this particular case. And this is all done by one nice call with a LangChain framework, for example, in that case using the Bedrock embeddings method. So the whole documents that you have can be indexed with one call, as long as you properly connect it. And in our case, if you want for the experience, because we also document things in Markdown format, we did see that there is a benefit into using the document splitter based on the sections of the document rather than indexing the whole document as a document. That was the end of theory and a little bit of specifics now. On the task decomposition of the problem of I'm an on-call engineer and I need to react to a ticket that is coming. I gather the configuration, running some CLIs maybe, get the metrics from my dashboards, collect the knowledge from my knowledge base, generate hypotheses, and compare the hypotheses that I have in order to make a decision on what to do next. And I will focus on a particular example here. Get metrics and build insights. I have a screenshot here of a drop. That's what I observe. There are two plots here, and there is one drop in the one of the two time series. I can have it in my time series database, and my Grafana can render it for me when I'm using it as a user, but it also comes with this beautiful plugin called Image Renderer that it can render it programmatically. So if I invoke through the metrics tool the image renderer, it will give me a screenshot of the Grafana dashboard or the panel of this drop. And now, if I'm a human, it's okay, I can see the image. If I'm an agent, what is going to happen? There is a nice paper from DeepMind here describing the difference between giving CSV data or JSON to a model from time series to figure out what type of analytics does it need to perform in order to see if there is a drop or an anomaly. Or if you give it an input, an image as an input, and figure out from an image, like if you upload to ChatGPT an image, you will see ChatGPT reasoning on what is happening in this image. It can do some very basic description of what is being observed. The same thing, and there is some research here from different organizations on how do we compare tabular data given to a model versus a screenshot of a plot that has been generated already. And if we bring this together, we can I will show you later how much more beneficial it was with the image rather than the pandas data frame, let's say. We are using this tool called PromptFu for evaluation framework. PromptFu is another open source tool built by some academics that is giving us the ability to track over time the pass rate of the prompt based on a benchmark dataset. And we have spent some time, and it was very important for us, to build this benchmark dataset. Actually, we call it Save2Bench. This benchmark dataset has the ticket description, the title, and everything that is coming to the ticket, and the outcome of what I expect to get from this ticket. Like, this is a hypothesis, or this is the drop in the traffic of the ALB because it was mentioned in this particular ticket. And over time, by having this data set available, is allowing us to have an evaluation-driven development process and improve our prompt based on the success rate on the tests that we have written. So we are entering a world of evaluation of the prompt as a guide of improving it based on actual data. I like PromptFu. It comes with not only simple test cases like it should have this word or it should match this regular expression, but also some LLM as a judge capabilities, like invoke the LLM to read the answer of the previous LLM and make a decision if it is matching correctly the expectation or the assertion. And in that case, the test is passing or failing based on the output of the second LLM. There is a con that the problem is that this is a local SQLite DB, but with a sidecar container that is fetching it periodically and into a remote RDS works nicely, and I highly recommend it. Now, yeah, this is an example of the assertions configuration in PromptFu. You can have just like a type of equals here, that the value that I'm looking for is this, because we have different environments, and sometimes we want to understand which environment is this particular ticket about. And we are trying to extract the environment information from the ticket. And also comes with versioning. You always remember versioning both the prompt and the benchmark dataset. Because as I'm improving my as I'm improving my test dataset, because my user is telling me it was a bad prediction, I'm getting back this bad prediction to my test dataset in order to improve my prompt. And then I'm improving my prompt because the accuracy suddenly dropped of the prompt because my user told me this is not good. So I'm improving my prompt and I'm improving the accuracy again. And this is a circle that is happening, and it's important to version both the benchmark dataset and the prompt. And the tool supports that. So speaking of human feedback, in that particular case, we expect the agent to generate traces to provide the explanation for the reasoning process. And the reasoning process is this thinking thing that you see in modern chat systems, and it's part of the agentic frameworks as well, that you see this output, if you want, in a form of logging of what was the reasoning taking place. to confirm the hypothesis, for the user, we want the ability to have this type of thumbs up, thumbs down on every prediction that is happening, on every ticket that is coming, in order to get the feedback back to the system. And I will mention, since we are SREs here, I will mention the different metrics that we need to have in place. First of all, we need the system metrics. You are very familiar with all these, because these are typical metrics that an API also has, like the latency or the average duration of the average latency, or the number of tokens consumed, because that has a cost behind it. So the number of input tokens together with the output token and form the total tokens, and the tokens, if you've seen the discussions from the previous talks, have a cost. But there is also the concept of task metrics. And the offline evaluation that we have seen with prompt.foo is an example of a task metric, the pass rate that we had on the assertions that we configured. Did my prediction on what is the environment had the proper environment, or did it give me a wrong prediction? And the human feedback here system is another task metric, like the thumbs up or thumbs down is written as the ground truth, a validation of what we have, so we can get it back to our test data set and challenge the pass rate of our prompts. So we can force our engineers to write better prompts in order to improve the predictions that the model is doing. Task completion rate, human intervention rate, if not helpful or helpful. If it's not helpful, maybe you can even ask our user to put the right prediction so we can get it in our test easier. And there is the third category of metrics, the tool metrics, that is available through the agentic framework. And in that case is which tool has been selected. Was the selection of the GitHub tool, for example, that we've seen earlier, correct? At that moment in time, I was asking for services, but it called the getPods API. Was it correct? No, I was asking for services. It should first get the services, find the deployment, and get the pods to figure out what is happening. So the tool selection accuracy is something that we need to track and store in order to evaluate whether the reasoning process is happening as we expect. And the same with the success rate of the tools and the parameters that are passed. For example, did we pass the reviews parameter properly to the get deployments, or was it passed by asking the user again what is the namespace? Now, if I will summarize the learnings here, is that we need to have this evaluation, which model, how much number of the tests we're passing from the benchmark data set, what version of the prompt has been successfully passed all these tests through the revisions, and finally measure through different metrics the task, the performance, and the things that we have seen. So now we are entering the moment of cooperation between the agent and the engineer, between the human and the agent that are trying to collaborate and perform the task of assisting each other onto figuring out what is happening to the environment. And in the Grafana, for example, you can have nice annotations of the moment of a deployment in an environment. Giving this through the image rendering to the user and to the model, you can expect the user to see what do I see here is that I have a drop in the traffic or the request per second, whatever this graph is, and it's right after the deployment that happened. So maybe the deployment impacted the request per second on this service. And we expect the same, so I see a drop for 10 minutes right after the deployment. That's what I would say if I would see this graph. Giving this image input to the model, instead of giving a JSON with all the floating points over the time series that it has, it can do the thinking and it can say, to analyze these metrics, I need to, which is the Grafana dashboard, I need to use the image renderer tool. And the image shows a drop in the request rate for a period of 12 minutes, which is amazing. Here is another example. It not only finds this, but it also says that coinciding with the deployment version 4.2.4. So it is able to read from an image, and the fact that it has used the image and not a CSV dataset, it's easier for me to reproduce this and print the image in my runtime or print the image in my UI and see if it was correctly if I want to do the same intuition, if I want to do the same reasoning. So it ended up to the hypothesis that maybe this version of the deployment has caused a reduction on the system's capacity. So as you understand, this wasn't an automation, right? It was understanding, because we see the agent reasoning on what is it observing in a particular plot. Another example is the ability to generate hypotheses, and we have seen it, and the ability to extract these traces or the metrics that you want to plot, or you want to track historically what is the number of tokens, what is the latency, and everything. Very important, get the user feedback. So in the UI that is doing these different tasks execution, the first is we call it environment extractor to find which is the environment. So I can then go to my UIs and fetch, or to my dashboards and pass it as a parameter in order to fetch the appropriate metrics. And then the textual insights extract from an image what is happening. It gives a hypothesis here, and it says, this deployment of version might have caused reduction. If the user figures out that during the on-call situation that he's troubleshooting, because he's using it as an assistant here, is useful, they can give a thumbs up and we are good. I can even put it in the test dataset. If it's a thumbs down, even better, I will put it as a failure scenario, so my assertions will fail, and in the iteration of improving the prompt, the user will try to make the prompt more successful. So we are entering this circle. We love this in Amazon. We call it flywheel. There you are. Thank you. So we call it a flywheel that we, in that flywheel, we do the evaluation of the prompts, we refine the agents, we collect the feedback from the user, and we aggregate the results back to evaluate the prompts. And suddenly, through this process, we are getting out of the normal circle in order to deploy the new version and observe what is happening with the new version of the prompt. And this is increasing the user trust, because the user gave us the thumbs down, but then they see in the new version that we have improved it because we got their feedback, and we adopted their feedback, and we have refined our agent with a prompt that is passing the test that was highlighted by them that it was not passing properly. Lesson 2. Feedback as supervision. So all this information from the user should be tracked, should be written, should be visualized, should be measured against the performance of a team that is not longer building CLI tools, but is building agents and is building prompts and is collaborating with the agents to troubleshoot their experience of on-call duty. And the message here is that the agents learn with us. By giving them the feedback, by having this feedback loop, we stop teaching the agents and the models in the form of traditional machine learning training that we had in the past, but we started learning together by bringing more data in the context and improving the prompt and the reasoning process. So beyond automation, we are moving from a world of system reliability into a world of cognitive reliability, and so the metrics that we are using should change. And the task that we are targeting is no longer just the redundancy and the alerts and the uptime. Still, these are the objectives, but we are trying to have better discoverability. So how do I find the knowledge base in my internal wiki? How do I track the documentation properly? Explainability, how do I track the reasoning of the agent that it makes the right judgment in order to execute the tool? And this information, reliability used to mean uptime, but now it means understanding. And I strive to improve the understanding of the agent on what is happening, and I'm learning, and it's learning from me through this iterative process. Key takeaways to get some questions is to have unified tools, so both the agent and the human can access the same information. And the example with the image is amazing, because instead of maintaining two tracks of tools, one for the agent and one for the user, wouldn't work nicely. The reasoning loops, the techniques that we have seen, the different prompting techniques, and the evaluation culture that challenge what has been built, get the user feedback, and improve it. Maybe if you allow me a new definition of the site reasoning engineering, and for some future work, we are still trying to do that, to get the user feedback back into the offline evaluation framework, and the concept of improving the model from you are an image analysis assistant to you are an SRE engineer and into the building the loop and repeat the loop by introducing the reasoning is also helping us learn how to better prompt to the system and improve the pass rate overall. So the call to action here for us, a message from me is that we have to make all our expertise addressable, document what we think and what we work with. That is something that the agent can also use in order to learn from our learnings and continue this process. Thank you.